welcome to the presentation of the project LoopX Marseille. I'm Michele Mossi, CEO and founder of Geste Engineering, a Swiss and international engineering office mainly involved in the design and the development of transport projects. But first of all, happy birthday to the Hamburg Test Gallery Hagerbach. And thanks to the Hamburg team for giving me the opportunity to present you an interesting innovative project we are promoting now, our Loop project, the LoopX Marseille. The LoopX Marseille project is a new concept of passenger transport system. You will discover it. It is flexible, driverless, sustainable, and moving at high frequency. As you will see, it is mainly underground in densely populated areas. And you know, as soon as we have an underground infrastructure, Hamburg office is certainly involved. And on a smaller scale, also my office, Geste Engineering. As I told you, I'm a Swiss engineer, and as you know, we have in Switzerland a large experience in underground infrastructure, and Swiss engineering companies have been pioneers in the construction through the Alps of long tunnels for passengers and freight transport. At the end of the 90s and at the beginning of this century, in Switzerland were being designed two important north-south railway axes, two new links through the Alps. The first one, called Alplansi-Lötschberg, with its base tunnel 35 km long, and the second one, called Alplansi-Gotthard, with the Gotthard base tunnel of 57 kilometers. And in this period, between 1994 and 2004, even though both Alplansi-Lötschberg and Gotthard project were the primary concern for the Swiss government and its investment in transport infrastructure, in the Swiss Federal Institute of Technology, with the support of private companies, we were looking to develop an innovative underground transport project, the Swiss Metro. I had the pleasure of leading this project between 1999 and 2004. This project aimed to develop a new sustainable transport system, entirely underground, moving at high speed in a tunnel under a partial air vacuum and pushed in magnetic levitation by linear electric motors. This is the same concept and almost the same technology now dusted off by the different Hyperloop projects. Hamburg collaborated with us in the development of this exciting project, which unfortunately had to be stopped in the year 2004 due to the lack of funding, probably because it came 20 years too early. But the lack of success of the Swiss Metro project has not stopped our desire to innovate and to design a sustainable and efficient mobility solutions. After Swiss Metro, I was involved in several projects, each with its own small part of innovation. But I had to wait for the arrival of the various Hyperloop projects to start developing an innovative project again. And this is the project I'm presenting you now. At the beginning of last year, I was asked by two people from the Marseille area, Guillaume and Mathieu, to think about an efficient solution for transporting people in this daily congested area. They were not transport specialists, but were looking for a solution for their region. Guillaume was active in the financial world and Mathieu in politics. At that time, I was working on driverless metro lines and on the Virgin Hyperloop project in Los Angeles. And this last project certainly inspired me to find a solution with Guillaume and Mathieu. Hyperloop inspired us by its operating concept, based on small vehicles on the pods, transporting 20 to 30 passengers and circulating in a dedicated tube at high speed and very high frequency. These pods move alone or coupled, forming convoys, for example, of 6 pods. They can reach 800 kilometers per hour, and in a convoy they follow each other a few meters apart. Hyperloop could be a sustainable solution for passenger mobility on long distances. But Aix-Marseille-Provence area is not the United States or the Middle East with huge distances between cities. In fact, this area is a metropolis of almost 2 million people distributed in 92 municipalities with smaller distances, 4 to 10 kilometers between them. So for this region, the 800 kilometers per hour of the Hyperloop are not realistic. Hyperloop cannot be the solution we are looking for. With these 92 municipalities, Aix-Marseille-Provence metropolis is characterized by several small and medium economic centers and a fragmented distribution of residential areas. These specific features lead to multi-directional passenger flows and not only concentrated on a main corridor. In addition, the public transport network has limited coverage in this region and is not sufficiently efficient, so people prefer to use the car, which covers 96% of the modal share of passenger transport. And of course, this huge share clearly leads to a saturation of the existing road network and an important increase of air pollution. And now, in this specific context, what mobility solution could I propose to my new friends Guillaume and Mathieu? I summarize. We were looking for a public transport system with ambitious characteristics, efficient in terms of speed and frequency, comfortable for all passengers, young and old, easily accessible and capable of easily and quickly connecting the different quarters and centers, flexible, capable of adapting to both peak and off-peak hours. Of course, sustainable and innovative to attract young people and realistic in the short term. And more concretely, the new system should be able to connect stations 4 or 5 kilometers apart at a speed of around 130 kilometers per hour. It should be able to run on a network of some 100 kilometers and to carry between 100 to 10,000 passengers per hour. It should ensure very frequent departures to reduce waiting time at the station. Its infrastructure should be fully dedicated and partially underground that provides flexibility and easy access to high-density quarters. The system has to be safe and reliable. And finally, of course, it has to be sustainable. Thus, have low energy consumption and infrastructure and operating costs have to be low in order to ensure profitability. The system performances can unfortunately only be partially covered by the existing conventional solutions. Train and metro are not flexible enough. Vehicles are too long for off-peak hours and their infrastructure costs are too high. Tramway and urban buses are mainly designed for shorter distances and their low cruise speed is certainly not attractive. So a new solution is necessary. It has to be a bit of a metro, a bit of a Hyperloop, a bit of an autonomous car. We haven't yet found a good name for it. For the moment, we call it a loop and a vehicle a pod. But more precisely, what is a pod? First of all, it is a fully automated road vehicle with conventional tires. It is of about 10 meters long, and its capacity is of 10 seated passengers. Its maximum speed is 130 kilometers per hour, the same speed limit on a classical motorway in France. Its motor is based on a hydrogen-powered fuel cells. It is driverless. It moves alone or coupled by automation with other pods, thus forming a convoy of 2 to 5 pods separated from each other by only a few meters. And its infrastructure is very simple. Underground, it is composed by single track and fully dedicated tunnels. And then on the surface, by always fully dedicated runway, which could be partially covered. And the pods, the vehicle, like a classical car, move on classical road surfaces. Of course, the network has stations, mainly underground, and switches and crossroads. Stations are on bypass, so that the stopping of one pod does not prevent the following pod from going straight to the next station without slowing down. The tunnel diameter should be limited to 4.5 meter, so limiting the construction costs. And safety is ensured like in a metro line, with safety shafts every 800 meters and ventilation shaft every 1.6 kilometers. Now, for a successful development of an innovative project, risk management is fundamental. From a safety point of view, collision is extremely improbable. The automatic system keeps the vehicle at a safe distance, and as already said, pods move in a single track and fully dedicated infrastructure, so collision should not be a problem for our loop. From the legal point of view, the application of existing norms coming from conventional road and driverless metro environment will greatly facilitate product development and homologation. We have to reinvent the legal framework. Also, this risk is mitigated. And from a technical point of view, the main involved technology are existing and proved. We put them together. And the innovation should be limited to the automation technology, operating concept, and trip reservation. Let me now give you just the two words about this operating concept that combines the advantages of mass transport and demand responsive transport. At rush hours, pods leave when full every 10 to 60 seconds. They leave alone or in convoy, depending on the trip needs. And when a user arrives at station, say station X, he announces his destination. We say station Y, and then he is a director to the pod that ensure the fastest trip to the station Y, also minimizing stops. At off-peak hours, if no pod is scheduled to arrive at station X within 5 minutes with the destination station Y, a new pod is injected in this station X, guaranteeing a maximum waiting time at the station of 5 minutes. But it's a lot of words. Sometimes a little video helps to understand the concept better. Look at this.
Living in a metropolis means enjoying all it has to offer. But often, because of traffic jams, transport problems, and pollution, we start to dream about the city of tomorrow. But there is an economic, ecological solution, the loop, a dedicated road network where autonomous electric vehicles silently circulate. Let's take a closer look. It's a transport system designed for multipolar cities, connecting entry gates of a territory to historic centers, tourist areas, places of employment or study. Residents are connected and neighborhoods opened. Containing 20 seats, the pods allow a high frequency even during off-peak hours, then face the peak hours by forming convoys, useful on game nights. Artificial intelligence regulates traffic and ensures the safety of travelers, optimizes energy expenditure, and reduces journey times. Connecting, for example, the city center of Aix-en-Provence to the St. Charles station in Marseille in only 15 minutes. The Loop is a world first, a new way to think public transportation, create links, and a real technological showcase for the Aix-Marseille region. So, what are we waiting for?
Let me come back to the network. The Loop Aix-Marseille transport system is now developed for the specific area of Aix-Marseille-Provence. But it can, of course, solve the mobility problems of many cities and metropolises in the world. So we are open to study the development and the deployment of our loop on other areas. But concretely, who are we? Currently, the project is supported by private investors and engineering companies. Of course, the company Loop Aix-Marseille, which is responsible for financial engineering, for the fundraising, politics and promotion. The project development is directed by Geste Engineering, so responsible for the project management, for safety, and also for the design of the transport system, its equipment, automation technology, and operation concept. Hamburg Engineering is very active on the project, responsible for tunnel and infrastructure, the most expensive project costs. The design of stations, their architecture, and their urban integration is ensured by architecture cabinet Vera Broese, who is also involved in the proposal of the passengers' experience. For traffic, mobility and operation, we can count on the important support of CITEC, a traffic engineering office. And finally, the Research Institute ISBA of Marseille give us the necessary knowledge on the local geology. And the schedule? When could we connect in 15 minutes Aix-en-Provence with Marseille? We are now leading the opportunity and feasibility study, which will be followed by the conventional project design and the industrial development of the transport system. The construction of a pilot network is expected to start in 7 years, and the first passenger should board in 10 years, in 2031. Now, let me ask a question to my partners, Mathieu and Guillaume. First of all, Mathieu, you have created a private company to design and build a new mass transport system, the Loop Aix-Marseille company. What public support do you expect to get for your project?
We aim to create a transportation system that stands without subsidies, but we have to convince both safety regulators and local authorities, including Aix-Marseille-Provence Métropole and the state administration. We think that early implantations of the loop have to be concession. It comes from the situation we know in Aix-Marseille. The metropole and the main city are in dire straits. It's the first constraint and the major relationship guideline with the public sector. We need to be frugal by design. Look at the bright side, it's also good news for the planet. Although it means we have to find financial support mostly from the private sector, we have an operational and lobbying partnership with other public stakeholders, like Chambre de Commerce de Marseille and municipalities. France just launched the State Agency for Innovation in Transportation sector, and we are eager to work with them since the Member of Parliament who passed the law stated us that it is kind of a great timing. Aix-Marseille-Provence appears to be a blue ocean for public transportation, and France shows an interest for innovation in the sector. So the traffic lights seem to be the greenest we could expect.
Thank you, Mathieu, for your answer. And now a question for you, Guillaume. you are starting your development with the financial contribution of small investors and the participation of well-established engineering companies. What are your next steps to support the development of the project?
The next big step, hopefully before the end of the year, is a A-series round with the aim to raise some 5 million euros, which of course is a lot of money. Since money doesn't grow on trees, there are numbers of milestones we must hit before that. First, we need to produce an opportunity study that will prove the loop can actually work technologically, legally, and economically in the context of Aix-Marseille, as well as a general concept that might be implemented elsewhere. Once done, we have to convince three kinds of people to get into the loop. First, we need to get the support from politicians and the administration. They usually go hand in hand, and they are basically our first clients and their main advisors. Then we need to convince a number of industrial partners that will bring even more credibility to the project and might turn out to be investors as well. And lastly, we of course need to convince investors, professional investors, that is venture capitalists at this stage. The great news is that we already have some very positive feedback from the public sphere. We have the support of the administrative body that will regulate the loop in France, and a number of high-profile government officials have already confirmed they are willing to help us. So in all, I think it's fair to say that the plan is coming together quite smoothly.
Thank you very much, Guillaume, for this positive news. Let me now finish with a citation that expresses our desire for innovation and our commitment to innovative projects. A citation that we certainly share with Hamburg office.
We aim to create a transport.
It is a sentence of a French writer and adventurer, Antoine de Saint-Exupéry. He said, "It is important not merely to foresee the future, but to make it possible." So I believe that through the Loop Aix-Marseille project, thanks to the strong and constructive collaboration with our partners, and thanks to the political and public support and enthusiasm, we contribute to make future possible with passion and expertise. So, thank you. Thank you very much for your attention. Happy birthday to Ambers Hagerbach Test Gallery again, and take care and Godspeed. Thank you. Bye-bye.
Working on metro projects, and in specific on the project LoopEM, which deals with the construction of a tunnel network for self-driving electrical buses, is a lot of fun because we have to find new and often unique solutions for every single project.
Hi, I'm Cristina Romani, and since I started at Amber Engineering, I have worked on several metro projects in different cities, as Paris, Brussels or Lisbon. I love this work, and how funny and interesting can it be? I am really enjoying this opportunity, and I'm happy to know that I'm contributing to a better future.